Bismillahirrahmanirrahim. Assalamualaikum. I'm Hafiz. Today I want to solve these questions, which is the questions is when a photocell is shown on with a red light, lambda 1 equal to 750 nanometer, and then with a green light, lambda 2 equal to 550 nanometer. The maximum kinetic energy of the photoelectron emitted by the green light is 4 times that of the red light. So here first we must to come up the information first. Info. So the question gives us the wavelength for red light, which is lambda 1 equal to 750 times 10 power of negative 9 meter. I already changed this nano into this, and this wavelength is for red light. And then the question also gives us the green light of a wavelength, which is lambda 2 equal to 550 times 10 negative 9 meter. This is wavelength for green light. And then the question also gives us the maximum kinetic energy of the photoelectron emitted by the green light is 4 times that of the red light. So here we can know that Kmax, it means kinetic maximum kinetic energy. Kmax for red light, we can write it as K1, while Kmax for green light, we can write it as K2 equal to 4K1. Why 4K1? Because the question stated to us green light is 4 times that of the red light. So we must multiply by 4 at Kmax of red light. So this is our informations. Okay. And for question A, what is the work functions of the photoelectric material in the photocell? So here we know that the questions want me to find W naught. Okay, the solution I will use another paper. Okay, these are for solutions A. We want to find W naught. W naught equal to we want to find. So here for to find the W naught, we need to use Einstein photoelectric equations. Yeah, I use blue color. And the formula for Einstein photoelectric equations is E equal to Kmax plus W naught. So we see for in our informations just now, we have lambda and we have Kmax. Kmax for green light and for red light. So Kmax we have here, so we didn't need to change to another formula. Also goes to W naught, we don't need to change it. So we just need to change this E, because in this formula we don't have any formula for lambda. So this E we can change it into maybe 2 formula, but from this I can change it become like this, C divided by lambda equal to Kmax. Just write it back as W naught. So this is the equations that we want to use to calculate the W naught. So here from the informations just now we have 2 lambda. That means we have 2 equations. For the first equations, we calculate the red light first, which is I write it as RL for red light, arrow AC divided by lambda for red light is 750 times 750 times 10 negative 9. And then Kmax for red light is K1. So K1 plus W naught. So here we calculate this first by using our calculator. HC is a constant number, so just calculate using our calculator, and then the answer here we get 2.65 times 10 negative 19 K1 plus W naught. This is our first equations. Okay, and then second equations is for green light, so I'll write it as GL arrow AC. Use same formula just now. Lambda for green light is 550 times 10 negative 9, and Kmax for green light is 4K1 plus W naught. Same as before, we calculate this first, and we can get the answer is 3.61 times 10 power of negative 90 for K1 plus W naught. This is a second equations. Okay, I use another paper. Okay, this I already changed into a better arrangements. Before this, the arrangements like this, so it's not better to calculate. So I use this arrangements for equations 1 to equation 2, and then from this we need to use elimination operations. Why we need to choose elimination operation? Because we want to cancel this k we don't want, we want to cancel it. It's easy for us to use elimination operation. So in my style, we want to do elimination operations. First we must do the line, and then we must see which K1 is the highest number, which means here we can see that in equations 2 K1 have 4, so automatically at equations 1 we multiply by 4. So all of these components in equation 1 multiply by 4, this multiply by 4, this multiply by 4, and this multiply by 4. And then this, when we want to eliminate, so we need to use minus sign. Yes. So we can using our calculator to calculate 4 times 2.65 times 10 power of negative 90, and then we minus this minus this, and we can get 7.00 times 10 power of negative 19, and then 4 times K1, 4K equal to 4K1, and minus 4K1 we can cancel it. So here we can eliminate this K1. So and then 4 times W naught we can get 4 W naughts, and we minus W naughts, and we can get 3 W naught. So from this, it's easy to us for calculate already, because it is a simple mathematician. So the right side and the left side we divided by 3, and then at the right side we can cancel this 3 and just contains W naught only. At the left side we need to calculate this, and we can get the answer is 2.33 times 10 power of negative 90. What's the unit for work function? The unit for work function is joule. So this is the answer for these questions. That's all from me. Thank you.